All right, guys, so we're going to look at quadratic applications. So the first scenario is a diver jumping off of a diving board. So the starting height, if you look at the way they labeled your x and your y axis, your height is your y, okay? So the starting height of my diver would have to be at A. The maximum height of the diver, if I look at my diagram, the height is C of that maximum point. The time when the diver hits the water, think about your x-axis as your water. So that time would have to be F. The height of the diver after t seconds, well, height was your y. After a random amount of seconds, that would have to be this point here at E. And then the time the diver reaches their highest point, well, the highest point is the maximum. So if I look at the maximum, the time was your x, so that would have been B. The second scenario is when they gave you a rocket. So they want to know how long the rocket was in the air. So if you are looking for how long the rocket is in the air, we need to look at when it hits the ground. So it hits the ground at 8 seconds. The greatest height that the rocket reaches, if you notice, it's going up by tens on your x-axis. The greatest height that we have is right here at this maximum. So to me, that looks like it's at about 260 feet. How high is the rocket after 1 second? Well, we need to zoom in on our graph to 1. If I follow that up, it intersects right here. It looks like that's about 110. After 2 seconds, about how high is the rocket? Well, if I zoom in for 2 and I follow it all the way up, I get this point right here. And to me, that looks like it's 190. At that point, it's going up. And if I look at 6, because they want to know after 6 seconds how high the rocket was, if I follow it all the way up to where my parabola is, I get this point right here, which is again 190. At that time, though, our rocket is already coming back down. So the next examples, they want us to identify the clue words and what we are trying to find. So it gives us a rocket equation again. It says, what was the starting height of my rocket? Well, remember, starting height clues you in that it was your y-intercept. So anytime they say starting height, that's what you're trying to find. So problem number 1 is what asked us for that. If you look at number 2, it wants to know what is the time. It took for the rocket to reach the maximum height. So think about our scenario. We had time as our x. Our height was our y, okay? So if I get launched, the time that our maximum would be, remember maximum and minimums, those are your vertex. So if I'm trying to find the time it took to reach the maximum, that would be the x value of your vertex. Number 3, it wants to know what the rocket's maximum height is. Well, looking at our scenario that I just drew, the rocket's maximum height would be the y value of our vertex. When did the rocket reach the ground? Well, when it reaches the ground, that would be right there on that x-axis. So it's asking for your x-intercept. And the very last one, what is the height of the rocket after 2 seconds? So if it's asking for the height of the rocket after a set number of time, that's just plugging in for x. Okay,